just let me know, and we'll take a look at that. And then I am recording this. I will upload it to YouTube for future reference, even if we end up not saying anything more than just to review. But yeah, if you have any questions, type them in the chat or on mute, and let me know what you need help with.
Could we do some of the heparin infusion calculation questions?
Oh, I apologize. I had my volume muted, so I didn't hear if anyone was talking.
Oh, I asked if we could do a heparin protocol. A couple of those questions.
Sure. Yeah, not a problem. And thank you. And I apologize for that. I'm not telling you, yeah, tell me your questions. And I'm like, I'm not hearing anything. And I realize it's because I muted myself. So helps if I know that. Okay. Yeah. So let me pull up that. And like I said, it's going to be the same type of questions that you saw previously. I'm going to save this as a 24 or 23 fall. So you'll see that in the when you go back to review, just in case if I add anything different. Okay. All right. Heparin. And I'll share my screen in just a moment. All right, so I changed up the question here a little bit, just so if you're seeing this and you're like, oh, why is that changed? So the heparin protocol is going to be asked basically the same way. The only thing that can really change is the patient's weight, right? So for this example, I changed the patient's weight to 230 pounds. The way the heparin protocol, the standard weight-based protocol, is presented is going to look just like this, where step 2 is what you have available. Step 10 is a repeat of the order, which is to start with to do a bolus and then start a drip. And then the questions are actually down below. So where it says answer the following questions, if you remember this from 230 to 2230, you had 2 questions. One was a bolus question, one was a flow rate question, and that's what you got. So you got 2 questions, 1 flow rate, 1 bolus, and that counted as 1 question for your test. I give you 4 questions, so that way you can practice this twice, basically. So, all right. So let me go through this for practice purposes. So we have our patient's weight at 230 pounds. We want to know what that is in kilograms. So I'm going to take that 230 pounds, divide by 2.2, and I'm going to get 104.54 repeating. You can do this one of two ways, but if you're going to get something with like that and you don't want to have to put it all in, you should be fine rounding to the nearest tenth. Okay. I wouldn't round to the nearest whole number. I'd round to the nearest tenth. But if you're concerned about that, just leave it like leave that 104.545454 and then just do your calculations off of that. But you should be fine rounding to the nearest tenth. All right. So once I know that we have 104.5 kilograms body weight, and we know that our initial bolus is 80 units per kilogram, that's what we're going to use. So we're going to take that to calculate our initial bolus. I'm going to take my 140.5 kilograms times my patient, or times my order of 80 units per kilogram. And then what you're going to get is, I think it's 83.63, but let me just double check. Oops.
I think kg is 104.5 kg.
Oh, I'm sorry. You're right. Yeah, I'm sitting there going like, what did I do here? I just wrote it wrong. Thank you. So we said 104.5, correct?
Correct.
104, thank you. All right. Sorry, I had a brain flub there. We're all allowed to have them. All right, 104.5 times 80 will give me 8,360 units. So we don't want units, though. We want to know, that would be how many units to administer, but we're not measuring units out. The question asked for how many milliliters. So that's why we have to go back up to the are available and see that our bolus dose is available at 1,000 units per milliliter. So I'm going to convert my units to milliliters by getting rid of units, converting it to milliliters. So 1,000 units per milliliter. And then you're going to get 8.36 milliliters, which you're going to go ahead and round to the nearest tenth. So 8.4 milliliters. Any questions on calculating the bolus? All right. So now for the drip rate, we're going to use the same patient weight, and hopefully I can write it down this time without messing that up. Good. And we start our infusion at 18 units per kilogram per hour. I always like to show that I'm crossing out my units just for completion. So I'm going to take my 104.5 times 18. I'm going to get 1881. 1,881. This is units per hour. Again, I don't want units per hour. I want milliliters per hour. So this is what you've done previously with the infusion rates for converting units per hour to milliliters per hour. So I'm just going to go back. I need to know what my IV is. My IV is heparin, 25,000 units, and then 250 milliliters, half normal saline. So again, just like I kind of talked through the bolus, I don't want units. I do want milliliters, 250 milliliters, 25,000 units. And that's going to give me 18.81 milliliters per hour. But we're going to go ahead and round that to the nearest tenth. So 18.8 milliliters per hour. So again, most likely that's what you're going to get is bolus, weight-based heparin bolus question, part A, part B. You answer both of them. If you get them both right, you get the question right. If you miss one, or if you miss both, you've only missed one question. So you don't need to worry about, did I miss two questions with this? This counts as one question, even though they're going to ask you to calculate a bolus and a flow rate. And most likely that's what you're going to get is A or B. On the rare occasion, you might get a part C where it's basically a repeat of, calculating the bolus. And then a new infusion rate based off of what it says. So if you go back in the protocol, steps 11 through 15 just basically tell you, after we look at the APTT, we're looking at their clotting time, and we're going to make adjustments from there. So if the APTT is less than 35 seconds, that means they're still clotting prematurely. And so we're going to rebolus with another 80 units per kilogram, and then we're going to increase the infusion rate by 4. So if the original was 18, we're going to bump it up to 22 units per kilogram per hour. The reason I'm telling you that is because if they tell you the APTT was 30 seconds, then you want to follow the directions for the APTT that pertains to what it says in the protocol. I gave you the example of 43 seconds. If it were 50 seconds, we would just say to continue the current rate. So we would not bolus. So if the question was, how much would you bolus if the APTT was 55 seconds? The bolus dose would be 0. You would not bolus. You would just continue whatever the 18 units per kilogram per hour, and you might need to calculate that fresh if that's the first time you're seeing it, or obviously just use the same answer that we got, the 18.8 for this particular example. All right. So, but because the example here says 43 seconds, then we're going to follow the directions here. It says to rebolus with 40 units per kilogram, and then to increase the rate by 2 units per kilogram. So the rebolus would be taking that 104.5 kilograms and then this time we're going to multiply by 40 units per kilogram. So 104.5 times 40 gives me 4,180. And then I'm going to convert units to milliliters using my same bolus dose strength that we used before. That was 1,000 units per milliliter. So that didn't change. And then we're going to get 4.18 milliliters, and we're going to round that to the nearest tenth, which should be half of the 8.4 we did previously, right? So 8.4 divided by 2 will give me 4.2. I wouldn't necessarily recommend doing that, but at the same time, you may only be calculating the post APTT bolus, so you may not even know the original bolus if we're in a testing situation. The new infusion rate it tells us to increase the infusion rate by 2 units per kilogram per hour. So we started at 18. So we're going to raise that up by 2. So our new calculation will be 20 units per kilogram per hour. So I'm going to take my 104.5 now times 20. That's going to give me 2090 units per hour. I'm going to use my available, which is my IV, to get rid of units and convert it to milliliters. And our available was 250 milliliters, 25,000 units. And I'm going to get 20.9. Is that right? Yeah, 20.9 milliliters per hour. So I don't need to round it because it's already to the nearest tenth. And in reality, you might only be able to set the infusion pump to like 20 or 25. Just so you know, just remember we're in the CCAC Allegheny campus math bubble. So we're just trying to make sure you can do the math, not necessarily what is clinically appropriate for some of these things. I actually have a feeling that a lot of these things could probably be, you could probably set the units per hour because it's probably able to do that, but I don't know that. You don't have to worry about figuring that out, at least not on this test. But if you see it clinically, you'll know it the next time. Hopefully you see it. So that's the heparin protocol. All right. Any other questions? Questions on the heparin protocol? Something you need to see again? Just let me know.
I had a question about one of the like very early questions on the practice test. It's number 6.
Mm-hmm.
And it's the for every 75 mLs of urine output, replaced with 30 mLs of water via peg tube every 4 hours. If the output for the last 4 hours is 200 milliliters, the fluid replacement volume would be blank. And I get 81 mLs, but your answer key says 80. And I just feel like I'm going crazy trying to figure out why.
Okay.
Where
So
the
let me see if I can find the same.
Okay, yeah, because those are different numbers.
All right. So, well, here, let's just do this.
I mean, I think I'm doing like the, calculation correctly, but I'm just not getting I'm like, maybe I'm not rounding the right way.
The other issue is I may have made a separate question and didn't change the answer. So, okay. So, go ahead and tell me the variables again.
Okay, so it's for every 75 mLs replaced with 30 mLs. And it's every 4 hours. And the output for the last 4 hours is 200 mLs.
All right. So let's do this here. So I've done this a couple different ways. So you probably have set it up appropriately. So I'm just gonna set it up the way I would set it up, and then we'll see what we get here, and then see if I've just made the wrong. My key might just be wrong.
I have a question, Angie. I have the one that's showing the original question being 150 mLs with the 600 ml, like what he had there originally. Where did you pull that other one from?
I don't know. It was from some drive folder that Connie sent in the email, the most
Oh.
recent email.
The most recent one. Okay.
Yeah, the most recent one. There's like a link to the practice tests, and this
Okay.
was the 240 practice test. And like when you open it, it's a drive folder, and there's a bunch. There's like extra ones. There's keys.
Okay. I'll have
And
to check that out because yeah, mine, I was like, well, that ain't what I had at all.
yeah, I just grabbed it from there.
Thanks.
Yeah. No,
There
and
were two different ones
both
that I noticed.
yeah, both of them are on there. This one that I'm working from is probably the most recent iteration of the reviews that were made, and that was back in 2020. You can see that the questions, the only thing that really changes is the numbers that we use. So what's most important is that you can solve the one and to just follow that same strategy.
Right.
So what I do is I take whatever the output is, the actual output, I put that over the expected output, so 200 over 75, and then I just multiply by the replacement volume. And
yeah, that's how I calculate it.
yeah, so for this one, I get 80 milliliters when I do this.
Okay, so 200 divided by 75, and then you just multiply by 30. Multiply. Okay, see, I was like taking the number, I was like dividing 200 by 75, and I would get 2.666667. And then I rounded it to 2.7, and then I multiplied it by 30. So I don't need to do any of that. I just do like straight 200 over 75 multiplied by 30. And then I do get it.
And then also remember, you do not round until you've completed all calculations. The exclusion is if you're doing kilograms, where you're doing like a weight-based. I think that would be the only exclusion.
Yeah, I've screwed myself over doing that before.
No, I'm glad that you brought it up because usually what I do is I just do 200 times 30 actually, and then I divide by 75. That's how that's how I look at these types of problems. You're not wrong with what you said. What you did wrong was, unfortunately, is rounding that answer. Just while you have that answer in your calculator, just multiply by 30, and then it should be fine.
Okay, thank you. I'm glad that I asked about it then.
Oh, no, I'm glad. Yeah, I'm glad you asked about it too. Yeah, and if and you're welcome, like in that that SharePoint or that OneDrive folder that I've shared with you guys, that's all. I have a whole bunch of practice tests in there. It's a little bit overwhelming, but you're always welcome to go through and look at some of the other reviews, like 110, the 130, 220, 230, and obviously 240. I would say the one that I'm working through right now is probably the most up to date. I did want to say that there is another type of question that might crop up on. I don't know if it will actually crop up, but I was told to by Professor Nanju to introduce you to a different type of reconstitution problem. So I want to show you what that looks like, and then try not to scare you, but just to show you what it looks like. And I'm just going to put it here in the middle of this folder. I'm just going to find a nice blank spot. Here we go. All right. So what I'm showing you now is called a reconstitution problem. You've seen this before. It's just that the way, or you've seen reconstitution questions before. It's just that the way this label is labeled is a little bit different. This is the type of reconstitution label that they look at Boyce. And so we're trying to create some more balance between what you're seeing on the different campuses. So in the event that you do see a question like this, now you'll be prepared. If you need this by itself, I have a separate video on YouTube that just says reconstitution, like question, and you can kind of go through that. But I want to show you what this looks like. So first of all, what you would likely see on a test is you would see this here, the order and the available with your label, and then the question saying how many milliliters would you administer. Now, what's tricky about this is when you look at the label by itself, it doesn't say anything about milliliters on the label, which is what makes this a little bit tricky. So you have to kind of do some searching to find the information you're looking for. Mainly what you're looking for is the concentration or the strength. So let's talk about that. So first of all, a couple clues. When it tells you it's intramuscular, you know you're looking for milliliters, right? Because it's an injectable. The other thing is the question says, how many milliliters will you administer? And then you have milliliters listed here as well. So you know that you're looking for milliliters. In a typical label, like let's take Dilantin, for example, you're going to have 125 milligrams per 5 ml might be the strength of one particular type of Dilantin. Okay, 125 milligrams per 5 ml. So we know that we need ml based off of what we're looking for. We know it's an injection or it can be used for IV, so it's liquid, but it just tells us on the label very prominently, it just says 500 milligrams. So you might be sitting there going like, well, what the heck? How do I figure out how many milliliters to administer? So here's what we're going to do. We have to look at the label on the side here. So the first thing I'll point out to you is you may remember this from last semester, pediatrics, safe dose range, right? So it says 0.375 grams, which is 375 milligrams. That's and every 6 hours. You can see that it fits within the safe dose range, so we don't need to worry about that. And we're assuming this is an adult, even though it doesn't say it is an adult, we can safely assume that it is. This with reconstitutions, if you recall, reconstitutions are powders that water gets added in the pharmacy, it gets shaken up and then given to the person to be delivered. So the most common example of that would be like amoxicillin. You go to the as a layperson going to the pharmacy, you pick up your amoxicillin. In the pharmacy, they add water to it to a certain line, they shake it up, and then they say keep it in the refrigerator, give 2 teaspoons twice a day for 10 days, and then that's usually how a reconstitution is experienced by those outside of the nursing profession. In this example, you might need to be the person that's adding the liquid to this or something, which is why you're seeing this. I don't know that would be the case, but everyone's going to be going somewhere differently, so we don't know. But anyways, so the next thing is we have to look at where it says for IM administration, tells you to add 2 milliliters of sterile water. So that just tells you what to add to it. What's more important to that is that there's an approximate total volume of 2.2 milliliters. So the 2.2 milliliters is a more important volume to look at than is the 2 milliliters. But the most important thing listed on this label is it actually tells you the strength of the ANSEF, which is 225 milligrams per milliliter. So it takes me a long time to just kind of show you where that information is, just because I want you to know that sometimes you have to look for it. And your clue is that you're looking for milliliters in your final answer, and the label just tells you milligrams. That's your cue that you're dealing with one of these types of reconstitutions, that you're going to have to look at the directions on the label. So then I would just solve it like you've been solving these things for what feels like forever. 375 milligrams, my order, over my available, times my quantity. And then you're going to get an answer of rounded 1.7 milliliters. So I have been told that there's a potential you'll see a question like this on your test as part of the reconstitution questions. I don't know definitively if it will or will not be for this semester, but I was told to start letting all sections know that this could potentially be on a future test I just don't know if that means next week or if it means next semester, and then you guys don't need to worry about it. Okay, yeah. So for yeah, so the answer key is wrong for the for question 8. So if you got 13.1, that's the correct answer. I'm assuming that's your question, is just why is the key saying 13.125? It would just be 13.1.
Could we go over problem 16 on the study guide?
All right, so just let me know if my 16 is different than your 16.
Okay.
Is it this one, the flow rate or the drop rate question?
Yes, that'd be correct.
Okay. Okay. So remember, for drop rate questions, you need 2 pieces of information. You need to know the flow rate and you need to know the drop factor. The drop factor is given to you. It should always be given to you, but if you have like ATI or NCLEX and it says something about microtubing, then the drop factor for that is 60 drops per milliliter. But other than that, it depends on the tubing, because it could be 5, 10, 15, 20, 25. It could be any number. It just depends on the actual tubing. And what that basically just tells you is how many drops equals 1 milliliter. All right. So I need 2 pieces of information. I need flow rate, which tells me 120 milliliters per hour, and I need the drop factor, 15 drops per milliliter. And you'll notice that I crossed out the 500 milliliters of dextrose 5% water. The reason I crossed that out is because it doesn't matter how full the bag is. I just need to know what the flow rate is. So that's why, if you're wondering like, well, why don't we do anything with that 500? That's why. It's not what I need. All I need are 2 pieces of information: flow rate and drop factor. So if they told me 500 milliliters, dextrose 5% water, infusing over 2 hours or 3 hours or 4 hours or whatever it happens to be, then yeah, I would need to know that, because then I would have to figure out what the flow rate is. But in this example, they give us the flow rate. So I'm going to make this a little bit easier on myself. Because I know I'm looking for my drop rate in drops per minute, I'm going to convert that hour to a minute, or to minutes. So 1 hour is the same thing as 60 minutes. Then I'm going to multiply by my drop factor. And then I'm going to get 30 drops per minute.
Okay, I got the same thing. It was just I did it different. I did the 120 milliliter over an hour, and then multiplied that by the 15 drops per milliliter. And then I got 1800, and then just put that over 60. And I got the same answer.
Perfect. Yep.
Okay.
Yep. You're doing that right. I just what I've done over the years and what I've encouraged students to do, but you do whatever is easiest for you, is I just convert hours to minutes before I do anything else, just to kind of simplify the process. That way it's 2 steps, right? Flow rate times drop factor. But what you did and what you explained to me is exactly right.
Okay, as long as I get the same answer and we're good.
Exactly right. And then it was good because if you get like that 1800 drops, you probably forgot to convert hours to minutes. So that's why it's also a good idea to make sure you're writing your units out so you can see if you need to account for that if you're not in the habit of doing that. But yeah, you're doing that. You're doing that right. Good job.
Okay, thank you. While we're looking at the drops per minute, could we also do just 17 because it's right there below it?
Sure. So again, we're going to follow the same procedure, right? So flow rate times the drop factor. So take a few minutes and then actually hold on one second. I want to change a couple variables here. All right. So I changed it to 150 milliliters within 2 hours, and the drop factor now is 15. So what I'm going to ask you to do is go ahead and try and solve for that, those new variables, and then put your answer in the chat, and then I will confirm your answer.
Okay, thank you.
Oh, you're welcome. And this is for everyone to participate. And if you're not 100% certain, but you want to give me an answer, just send it as a DM, and then only I will see it. So. And I am just waiting a few minutes. So those of you that answered, just be patient. I'm looking to see before I confirm or deny. All right. So before I answer, remember, you can only give someone a whole drop. You can't give somebody a partial drop. Okay. So always round to the nearest whole drop when you're doing these types of things. So to be consistent, I'm going to do what I told you I'd do previously. I'm just going to take the flow rate times the drop factor. And then what I'm going to get is 18.75 drops per minute. But again, I can't give somebody 3/4 of a drop. It's whole or nothing. So I'm going to round that to 19 drops per minute. Yeah, so if you got anything with a decimal, that's your cue that it's wrong, because you can't give somebody a partial drop. It's whole or nothing. Now, what's really going to be annoying is if you've done any work with drop rates in an actual clinical setting, you may only be able to set the pump to 20 or 25, you know, and so that would be the determining factor of what your actual setting is. But remember, we're in the CCAC Allegheny campus nursing 240 math bubble, and so we're just going to make sure we round to the nearest whole number when it comes to drops. Okay. So again, if you come back into this, the 23 fall 240 practice, the key is all going to be wrong. So just, I apologize in advance for that. So I'm also going to get rid of the stuff at the beginning here, because that's more for okay. So many things obviously are already worked out. I didn't work them out additionally, so.
For this practice test, you said this is the one that was most updated, correct?
Correct. Yeah. So I just made it, and it's currently being saved. And then when I close out of it, it'll be finalized and you should be able to download it.
Okay. All right. I just wanted to make sure I was, practicing the right questions and having the right key for it. Because
yes,
I know there's two different ones.
Yeah. So, well, the one that's not labeled 23 fall, there is no, the questions are still, if you go to the other practice questions, the keys are there. So this one that I just made is just a lot of them are the same questions. I may have just changed a few things, so the key won't be applicable for the one I'm working through right now, because obviously I changed the patient's weight, so that's going to be a different key. So I'm actually going to get rid of this key, because I'm just going to highlight it in red because it's not up to date. But if you look at the practice test for the actual spring 2021, that I've left alone, and so that one will be correct as far as labeling, or as far as the key is concerned.
All right, thank you.
You're welcome. But the ones I've changed, I went through and you can see what the key is. So, but if you go on to the practice set, like I'm in the 240 folder right now, there's a 16 fall nursing 240 practice testing key. That should be correct. There's a 23 spring nursing 240 orientation letter. Like that should be correct as far as the key is concerned, excluding that one that's like 13.125. I don't know why it says that. Unfortunately, some of the things are repeated just because that was on me and I haven't had a chance to update those. I just kind of leave them up. But if there's something you're getting and you're answering and it differs from the key, that's a great thing to email me about and just say, hey, I'm getting this. And then I'll just tell you, most likely the key is wrong. But if you're not 100% certain, email me. And I'm putting my email in the chat right now.
Could you remind me about the question 20, like the insulin syringe one?
Mm-hmm.
What arrow do you put where? I know it's like whatever solution is going to be closest to the plunger. I think I remember this being like kind of a, I don't know, like a confusing issue last semester.
So
it's like I think the arrow goes one place, but it's like it actually goes in another place because it's whatever solution is wherever in this syringe.
So just for future reference, when you initially go into the practice test link, before you go into any of the other subfolders, it says there's like a mixed syringe, mixed insulin syringe, like it's a PDF, but there's also a Word document. If you open that up, you'll see where I'm getting this information from. It's in the textbook as far as how they do this. In reality, it all mixes. You guys have probably done mixed insulins at this point, and you realize that the only reason you're doing the clear before cloudy is just so you can see what you're drawing up. But once they're all pulled in, it's all mixed. So there's no separation. This is all hypothetical, which is one of the reasons why I hate this question. But it's not up to me to choose which questions you get. So first of all, it always tells you to mark the syringe. So in this particular example, it's always B. And the reason it's always B is because it's the only syringe that's measured in units. Okay. We don't need to do any converting for units to milliliters because we don't have any labels to do that. Even if they give you a label that tells you units per milliliter, you're still going to use the unit syringe because that's the standard for insulin. So the first thing I always tell people to do before you worry about any marks or arrows on your syringes, always write, especially if it's a paper test, what you're being asked to do. So the solution amount to be drawn up first, you know you're going to do the 22 units regular first. So I would just make sure you write that down, even though that doesn't tell you to do that. I would just make sure that way there's no misunderstanding of what's being drawn where. And then your total, you're just going to add those up, right? So 22 plus 36 is 58 units total. So it tells you to make 2 arrows, one for the solutions drawn up first, and then the correct total medication level. I always start with the correct total. So I'm going to make a mark at 58. That's my total. And then where it gets confusing is the solution you drew up first is going to be, like you mentioned, closer to the plunger side. So that means your correct medication, or the 22 units, exists. You're going to make another point at the 36 mark, which is where things get a little bit crazy, but I'm going to try to explain this why. Your regular insulin is in here. The 22 units of regular, it's going to indicate R, is between 36 and 58. Okay. So that's technically how you're supposed to mark your syringe. You don't need to do what I did with the enveloping like thing to show you where the 22 units is coming from, but you would make a mark for this one to be technically correct. You'd make a mark at 58 units, and then you'd make a mark at 36 units, because 0 to 36 is where, so this range here, so from here to the end, that's where your NPH is. So if I'm being like extra cautious and I don't want to make sure that my instructor knows that I know what the heck I'm talking about, even though I don't agree with the way this is situated, this is probably how I would mark my syringe, just to be on the safe side. But my hope is that they start to, like, if they haven't done so already, phase this question out.
Angie, just for the record, I have answered pretty much how he just wrote it, and I've written the brackets for like where the regular goes, just for that reason, to be like extra, and they were always good with that. So
yeah, I just remember it being confusing. I don't think I missed it, but I just wanted to make sure that I don't know.
Yeah, I gave them more than they did, just so that it was clear.
I know what's helped me in the past was thinking, I just say clear, then cloudy. Like I say that in my head before I like mentally like write down the arrows that mark it. Like clear, then cloudy.
You got it. Yeah, and I would even say like probably even more, because regular obviously seems to be the only one that is clear. So I always think regular first. So. And really, I think the only reason you're doing the regular first is just so that way you're making sure you're putting the right amounts in the syringe. It probably doesn't matter. Like if somebody was at home mixing their own syringe, first of all, they probably have 2 different syringes for regular and their delayed insulin. But if they were doing it themselves, they probably wouldn't do the same thing. And I mean, unless they're trained appropriately, which is probably the case. Like I've said, I probably have this recorded. It's probably like a repeated thing. If it were up to me, I'd get rid of this question because I don't think it's a math question. It's just procedural question. And we're trying to demonstrate something that is better demonstrated than it is drawn on a piece of paper. So I'm sorry. It's not up to me that this is here. So I try to just make it simple. Okay.
All right, I have one more that I should totally know how to do it. And I know I missed it on the first test last semester, but number 24, this insulin, or the normal saline with 100 units of insulin infusing at 15 units an hour. What is the flow rate?
So this question is the exact, or you're going to answer this question the same way we did the infusion rate here, right? So you're going from units per hour to milliliters per hour. So it's always, whether we're talking about heparin or insulin, it's pretty much the same procedure. So as a kind of like looking at it like a bird's eye view, I'm going from one flow rate to another flow rate. There's a reason I'm telling you all this, just because it helps with how to start it. The flow rate they give you is in units per hour. The flow rate they want is milliliters per hour. So it gives you an idea of like kind of how to set this up, which is good practice for when you get to the heparin protocol. So what do they tell you? They tell you 15 units per hour. And then I need to convert units to milliliters, and I'm going to do so using the IV that they gave me. So I have normal saline, 500 milliliters, 100 units, regular insulin. So 100 goes here, 500 goes here. And then I'm just going to run that calculation. So I do 500 times 15 divided by 100. And I'm going to get 75 milliliters per hour.
Thank you. I knew.
Oh, you're welcome.
One, but
and some of these, like, I know that nursing students really have, or at least a good portion of nursing students, I won't say everybody, don't like the dimensional analysis. But unfortunately, when it comes to like flow rate questions, doing ordered over have or ordered over available just doesn't work. So you kind of, I think it's easier to explain it how I've shown it. You may not agree with that, but it's easier for me to show you that I'm canceling out units. I'm left with what I want. And if I can get you in the practice of setting up, and all we're doing is doing a conversion of one flow rate to another flow rate, and then just practice it, hopefully it makes sense. And I would do 23 the exact same way. I have the flow rate 1250 units per hour. I have my IV 500 milliliters, 25,000 units, and then all I'm doing is converting units per hour to milliliters per hour and converting units to milliliters.
Funny enough, I could do 23 with no problem. But then 24, I'm like, wait, is this the same? I don't know.
It's the exact same, except that it was worded slightly differently, right? So like in 23, we gave you the units per hour first. In 24, we gave you the IV first. It doesn't really matter how it's written. It's just you get to decide how you want to assimilate everything. So
Thank you.
you're welcome. All right. So I will be back on doing 240 again this evening at 6:15. And then I'll also be here Thursday, 2:30 to 3:30, and then 6:15 to 7:15. If you can't make any of those other times, I will be recording these. I get often asked, will they be the same reviews? I'm going to do exactly what I did here. Some of you are going to ask the same questions. Some of you are going to ask different questions. So I can't tell you if it's going to be the same or not. But if you don't want to attend, you don't have to. And like I said, I will upload them either later tonight or tomorrow. And then for Thursday, it'll be later Thursday or Friday. That way you have time to review them over the weekend. If you can't come on any other time, I gave you my email address. You can email me any other questions that you might have. If I don't see you, I wish you good luck. Please let me know how you do. Hopefully I don't have to see you for remediation, but if I do, I'm here to help out. Just know that you're almost done. You have less than a semester to crank out, and then they're going to let you work with real people soon. I know you already are, but all right. So I'll leave it at that. Thanks for attending, and
Thank you.
you're welcome.
Thank you.
Thank you.
Thank you.
Thank you.
Nice to meet you. Yeah.